Hey everyone, hope you're doing great. This is Algo Conqueror. Today we are going to discuss the problem intersection of sorted arrays. And this is a problem of two-pointer section in InterviewBit. Let's get started. So we are given two sorted arrays. Let's take the array 1 as 1, 2, 3, 3, 4, 5, 6, and the array 2 as 3, 3, 5. And the common elements in both the arrays are 3, 3, 5. So we have to print this output. So how will we approach this problem? In the first step, let's say I I traverse through the second array. Now the second array has 3, so I'll check in the first array if there is any 3. So I found a 3, so I'll mark it as some invalid number like -1. Now I move to the next element, and now it's again 3. Now I'll traverse the array. If I find a 3, I'll mark it as -1, and simultaneously I'll add it to the result so that we can return the result. So we have two threes now in the result. Now we are at 5, so I'll traverse the array. I found a 5. I'll mark it as -1 and add this 5 to the result. So we got the result. So what do you think is the time complexity of this approach? Time complexity would be O of n square, because we are traversing for each element in the second array. We are traversing the first array for each element in the second array, so we'll get the time complexity of big O of n square. So this was the brute force. I'll write it down. This was the brute force. Now let's get to the optimized code. So I'll just copy this. I think, just wait a minute. Now let's get to the optimized approach. So let's start. We are done with the brute force. Now we are going to do the optimized. So this is the given array, and now what will be the optimized? How can we optimize this? Let's take two pointers here at the starting of the two arrays. This is kind of the merge technique which we use in merge sort. What this is similar to merging of two sorted arrays. Let's 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 find out how it is different from the merging. Now we are in the initial pointers. The first point is pointing to the first element in the array, and the second pointer is pointing to the second element in the second array, the first element in the second array. Now let's compare them. They are not equal. A is lesser, so in order to make them equal, which pointer should you move forward? Obviously, the first pointer which should be moved forward. So that's what I have done. Now let's again compare. Which pointer should you move? A is less than B, so the pointer of A should be moved. Now I have moved the A pointer also. Now we ended up with equal elements. Now, so this will definitely be part of our result. So what I'll do is I'll take this 3 and add it to the result. I have added it to the result. Now in the intersection we count both the elements of the arrays. So we should move the both pointers ahead after we find equal elements. So I'll move both the pointers ahead. So we are now here. Now again we ended up with equal elements. So we found another intersection of these arrays. So we will add it to the result. The element is 3, so we added 3 to the result, and now we move the pointers ahead. So now the pointers are here. So A is less than B, so the A pointer should be moved ahead in order to make them equal. I moved the A pointer. Now we ended up with again equal elements, so this will be part of our result. I'm adding 5 to the result. I have added 5. Now after adding 5, you should move both the pointers ahead. So I'll move both the pointers ahead. Now I have exhausted the second array and I am at the last element in the first array. If an array, if one of the two arrays is empty, then what can we conclude? There is no intersection of these arrays, right? Let's take an example. I have array 1 comma 2 comma 3 and I have an empty array. What is the intersection between these two? Yes, there is no intersection, right? So if we exhaust a single array, we will end there. So finally our result will be stored in this result. So this is the approach, and what will be the time complexity of this approach? So we are maintaining 2 pointers. The first pointer moves m times, considering m as the size of this first array, and the second pointer moves n times, considering the n as the size of the second array. So the time complexity will be big of m plus n. Previously, the brute force was big of m into n. Now we optimized it to big of m plus n. So that's how we solve this problem. I hope you understood the solution. Thanks for watching, guys. Thank you very much.